Well, hello everyone. Today we're going to be discussing the four basic mathematical operations and how to do them in binary: addition, subtraction, multiplication, and division. Let's start off with addition, which is obviously the most simplest operation, at least to my brain. And let's start off with an example. Instead of writing down the rules and then going from the rules to our example and solving problem, let's just start with the problem. 1100 plus, actually let me change that, 0011. So 1 and a 1 is 0 and a 1, right? 0 carry 1. Now how does that make sense? Now let's write down a rule. 1 plus 1 is 2, right? Now let's imagine this 1 and 1 is in binary. Well, 1 and 1 is 2. 0 1, reading this first from the right hand side, 0 1 is 2. So 1 plus 1 in binary is 1 0. Sorry, 0 1. It's just in habit reading from the left hand side. So 1 plus 1 is 0 1, which is 2 in denary. So how do we represent 0 1 here? Here? Well, what we simply do is 1 plus 1 is 0. And then 1, we won't write 1 here, but we'll instead write 1 over here because that's being carried, and then it will be added with the next digit. Oops. This needs to be added to the next digit because this is not a number on its own. It's not isolated. It's with the whole thing, right? So here we have 1 and 1 again, 0 1. 1 plus 1, 0 1. 1 plus 1, 0. And this is the interesting part. We carry 1, but there's nothing to be added with it. So we have to generate an extra bit. This here is an extra bit. The maximum number we can represent in 4 bits is 15, right? So if we ever have 4 bits plus 4 bits, 15 plus 15, the max we can get is 30, and we can't represent 30 in 4 bits, so we have to generate a new bit. And this is an interesting and important observation that was important enough to share. Let's move on to binary subtraction, which is also pretty simple, but a little more tricky than addition. I mean, who likes subtraction? We all like addition, right? Let's start off again with an example. Let's go 1, 1, 1, 1, 15 minus, let's say, 3, 0, 0, 1, 1. Actually, this is a little too easy, but let's go on. It's important. So this is 15 and 3. Also, let's solve this in binary so that I'm not lying, in denary. So this is 8 plus 4 plus 2. That's 13. And this is 3. The answer should be 16. And the answer is indeed 16 because that's 16. That's 8, 4, 2, 1. So that is how we do addition, and that's, if you do it, you can do it in denary to check if your addition is correct or subtraction is correct or whatever. So moving again to binary subtraction, we have 15 minus 3. We know the answer to that, but let's not write it first. So 1 minus 1 would be 0. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0. 1 minus 0 is 1. Obviously, 1. And here we have our answer, 8, 4. 8 plus 4 is 12. 15 minus 3 is indeed 12. However, in subtraction, the tricky law is when we have 1, 0, 0, 1, right? When we have 0 minus 1. What do we do then? What do we do then? So let's try and solve this. 1 minus 0 is 1. Now 0 minus 1, what do we do here? Well, the thing is that the 0 is not isolated, right? The 0 is not isolated here. So what we do is we carry a 1. We imagine that there must be a 1 there. So we carry a 1, right? We write 0 there, and then we carry 1 here. So 1 and 0, this 1 and 0 makes 2. So instead of writing 1 here, what we could just do is cancel this and write 2. Now what is 2 minus 1? That's 1. So 1, 0 minus 1, which is 2 minus 1, is 1, right? And 1 you can write in binary as that. That makes perfect sense. So here what we're going to do is, there's no 1 here, right next to this 0. So you'll carry 1 from here. 0, 2, 1, right? Now we're carrying 1 from 2. So we still have 1 left, and then 2. So 2 minus 1 is 1. 1 minus 1 is 0, 0. And let's check our answer. This is 8 plus 1, 9. This is 4 plus 2, 6. And our answer is 3, which is the right answer. Wow. Moving on to binary multiplication. Now, multiplication, as we all know, is repeated addition. So if you have been given a number 15 times, 2, what you could do is just do 15 plus 15, right? 15 times 2 is 15 plus 15, and you will get the right answer. However, that is not really a good method, because let's say we had 15 multiplied by 9. Well, are you going to be doing 15 plus 15 9 times? Well, you could do that if you wanted. However, there's a much better way, and let's try and solve it using that one. So let's go with the example 1100 times 0011, right? Which is 8 plus 4, 12 times 3, which we know is 36. So what we do is long multiplication. You must have learned this in school. If you're still in school and watching this, man, I'm not sure what you're doing. Or woman. Wait, you aren't going to be a man or a woman if you're in school. Okay. So 0, 0, 1, 1. Right? We're multiplying 1 with all of these numbers. We're going to be multiplying 1 again with all of these numbers. Adding crosses. 0, 0, 0, 0. 0, 0, 0, 0. Damn, I'm sweating. I'm literally sweating right now. I haven't turned on the AC. And I'm sitting without a fan. 0, 0, 1, 1, 1, 0, 0. I'm just adding all of these numbers. 0, 0 is 0. 1, 0, 0 is 1. 1, 0, 0 is 1. 1, 0, 0 is 1. And let's just, decode this number. It should be 36. So this is a 1, 2, 4, 8, 16. Interesting. Interesting. Have I done something wrong? Doesn't seem like it. Aha! There we go. There we go. You see how by writing our answer beforehand, I spotted the problem. There was a 1 missing here. And which is actually quite important. Because even if you know the methods, like I know these methods, right? But you could still make mistakes. So it's always good to, be a little humble. It's actually pretty hilarious. 1 plus 1 is 0, 1. And 1 plus 1 is 0, 1. We would get a 1 here. Right, and this makes sense. So we have 32 plus 4, 32 plus 4, which is indeed 36. Now, one more important thing with multiplication is sometimes you might get, 5 ones. Now, how are you going to add 5 ones? Well, what I like to do is create pairs. So 1 and a 1 would give me 0, carry 1. 1 and a 1 would give me 0, carry 1. And 1, well, 1 plus 0 is 1. So we're going to get 1. And then 1 plus 1 is 0, 1, right? And this indeed is 5. So that's just a neat trick how to add 5 numbers. That's how I like to do it. This is 5, and these all, well, this is 1 plus 1 plus 1 plus 1. I did not need to write that. Let's move on now to binary division. And division, we all know, is repeated subtraction. Also, a key thing to note here, since I'm talking about division, I might as well add this about subtraction, is that this method is only going to be used when we have a larger number minus a smaller number. And the same thing goes for division. The method that I'm going to be telling you is going to be for larger numbers divided by smaller numbers. A. B. Answer is going to be a whole number. Answer is going to be whole. Right. So let's say we want to divide 6 by 2. Right? That's 6. That's 2. And we know the answer is going to be 3. Or actually, you know what? Let's make it easier. 6 by 3. Oopsie. 6 divided by 3. And the answer is going to be 2. We know that. So what we're going to do is simply subtract 3. Subtract 3. This number here is 3. From 6 till we get 0. What we're trying to find out is how many 3's can we put in 6? How many 3's make up 6? And so we're gonna keep on subtracting 3 from 6 till we get a 0. So we subtracted it once, and we subtracted it twice, and then we got a 0. So our answer must be 2. Using that same logic, sorry, a little sick, we're just going to subtract 3 from 6 again and again till we get 0. And we're going to keep a counter, which is going to be our answer. This is our counter. And we're going to keep on adding 1 in binary to this counter. So 1 minus 0 we're going to carry. 2 minus 1 is 1. We're going to carry. 2 minus 1 is 1, 0, 0. Right? We're going to subtract 3 again. And we get, well, 0. So we subtracted once. We add 1 to the counter. We get that. And then we subtracted again. So we subtracted once. We subtracted twice. So we get our answer as 0, 0, 1, 0, which is 2, which is indeed the answer to 6 divided by 3, or 0, 1, 1, 0 divided by 0, 0, 1, 1 is 0, 0, 1, 0. And that's all there is to binary operations. I hope you learned something, and I have proved that I can maybe explain things a little clearer. That in and of itself wasn't clear at all. Anyways, goodbye. Thanks for watching. Really, I have to say thanks for watching. Whatever. Have a good day or night. Good night. Okay, I should really stop recording now.